I want to talk today a little bit about my company, Primer. I'm the CEO and founder of Primer. We're based out in San Francisco, but I've got an increasingly big set of teams out here in both DC and also New York. And we've raised about $54 million to date, most notably led with a Series B by Lux, based out of here in New York. And for us, the core challenge that we focus on trying to work is really captured by this schematic here. You can kind of think of the data that we've created in the world as being exponentially increasing over time. We've done a really good job of collecting that data. But unfortunately, the number of people looking at that data is at best increasing linearly. So what that creates is a delta between the information that we've got, that we should be looking at, and the information that we actually are looking at. And when you're in spaces like intelligence or finance, that delta represents a severe problem, and you've got to close it. But it's not one that's going to be closed by throwing more people at the problem, because people, frankly, are quite expensive. And even if you closed it today, you wouldn't close it tomorrow. So to solve this problem, we build machines that can read and write. We get very, very good at natural language understanding and natural language generation, and combine that together to start automating different tasks. So what does this look like when you start doing it? Well, you're not just reading and writing on top of one document, but you're actually able to take multiple documents across the entirety of the data set, both inside of the organization and outside, and start to combine them together to find insights, to correlate those insights together, to extract information, find contradictions, and ultimately generate outputs that would be kind of like the outputs that humans would be generating. And if you can do this, of course, you're automating a lot of human work, and obviously that changes the whole dynamic of different kinds of businesses. So we do this in not just English, but we do it in also Chinese, Russian, and new for us this year has been Arabic. And you can probably do some math as to why those are interesting languages for us. But we do the work in native language, and that's because actually the attention to that detail is really important, and we don't want to propagate the errors back through. We've got some major customers that we can talk about, some that we can't, but GIC is the biggest sovereign wealth fund out of Singapore. Walmart, obviously, $500 billion of revenue, and also through our partnerships with In-Q-Tel, we're deployed into a large number of intelligence and defense as well. And so we're able to kind of deploy different configurations of custom engines that work on top of text. And we're able to recombine these together in different ways to replicate different kinds of behaviors. So things like event detection and structuring of data, the ensemble engine, which takes multiple different data sources and combines them together, and also different things like the story engine, which is able to generate language in terms of the output. So here's an example of something we might do. We can take a set of 17,000 Russian language documents talking about Syria, and we can write a one-page report as an output. So here's an output here generated. It's obviously running on unclassified data, but you could equally run this on classified data and have your daily briefing for the morning. You can zoom in and see example here. One of the significant topics that emerged was around the FSB in court cases. It's also noted that the topic wasn't present inside of Western media, and calls out a couple of events there around migrants being detained for conspiring to aid ISIS. You can also see you'll actually render as well some nice visuals. If you're an analyst operating on top of this, this is a huge amount of work to find the events, geolocate them, and produce production quality graphics. So they're very, very happy to get that information back out. You can do this for more than just one document. You can do global event monitoring and analysis. Currently, this is done, again, it's unclassified, but do the math. This might look like your workflow in the morning, your daily traffic as an analyst sitting down at one intelligence agency or another. You scroll through this, and this is literally your job, is to go through these RSS-style feeds, looking for information, clicking on that, and trying to figure out what's actually happened in your world. Well, we're able to take that and take our different engines and start to automate that first analysis. So instead of sitting with this, you start to then get things like this, where you can render it in a map, but you can also see that play forwards and backwards through time. You can see the Russian language information in red and the English language in blue, and you can see the events unfolding, ordered and ranked by significance as they unfold. And finally, you've got, of course, summarizations for every event that's there. So a huge step forward in trying to help people understand what's going on in their world. One of the things we're really interested in this is fact-aware language generation. So we've heard a lot about language generation just recently. Some of the colleagues out of OpenAI released GPT-2. That was language generation, but it wasn't fact-aware. So, you could have four-horned unicorns. That's great. We can't generate random things and use that for intelligence purposes. That would not be a good idea. So fact-aware language generation is really key. You can kind of think of this as taking input text. So here's some input. Followers of the Church of Elon will no doubt be already aware of SpaceX's latest technical triumph and so on. So the challenge here is then, can you generate a headline to describe what's unfolding, right? So we input this text in, and then the output that we get from the model is this: the SpaceX Raptor engine improves fuel efficiency with full flow stage combustion prototype. So it's quite a nice result. We can compare that to what humans generate. And you can see the human sort of clickbait title, "The Impossible Tech Behind SpaceX's New Engine." So it's actually interesting, right? You've got a really nice training set to go with all the different headlines that have ever been written by humans, and you can compare that against what we're writing. But of course, any time you're into kind of unsupervised language generation, one of the hard things is, well, how good is this, right? So what we're actually able to do is to go and run this and run tests on top of this. So you can see here, and I'll grab some water while you read. You see a thing about a car accident, you've got two headlines. And one says, sleepy driver causes I-94 rollover crash that injured 4 Michigan state police say. And then the other one is 2 ejected from car in I-94 rollover crash, 4 injured. That's kind of interesting, right? So one of these is written by a human and one of these is written by a machine. And it's kind of interesting when I ask people, like, which one is which? So it'd be interesting to think, who thinks the first one was written by a machine? So about maybe 25%. So who thinks the second one was written by the machine? So sort of there across. And that's right. So the first one was human, the second one was machine. Now, we can go through this and actually see what sort of performance we're getting. And as we measure this, you can see the human performance actually runs down. You've got a 5-point scale from very good down to kind of very bad. And then you see what we're able to generate now with Primer. So on humans, we do about 87% are okay or better. At Primer, we do about 84% are okay or better. So actually really, really interesting in terms of reaching human quality. If we do this in a side-by-side comparison, we can see around 29% of the time, Primer is better. And we can see around 44% of the time on the high-volume model that humans are better. So we're getting close. Once that gets down to about 33%, right, we're going to be at parity in terms of being able to generate headlines to describe what's unfolding in the world. So really, really big step for us coming forward here, and something we're very, very excited about. But of course, you can do this not just for one story, you can do this for knowledge bases, and you can do this for all knowledge. So one of the challenges we undertook here was to go through and see if we could build a self-writing Wikipedia, right? So if you can start to kind of get near human-level performance of language generation, and you can do that in a fact-aware nature, you can start to generate knowledge bases. So we took a 3-step process to bring this together, and we were focusing initially on scientists. So we took 30,000 scientists on Wikipedia and took their profiles as of January 18. And then input into this, we put 650,000 scientific papers and around 1.2 million news articles that talked about the scientists. And then we used an RNN-based generative model to generate 40,000 new profiles of scientists. Now, what's interesting is we only started with 30,000 scientists on Wikipedia, so we're actually able to generate more than double the number of profiles for scientists that were there. And we can take a look at what one of them looks like. You can see here is Andre Karpathy. If you're in the computer vision field, you'll certainly know Andre, and you can kind of see Andre Karpathy is a researcher at Stanford University, a director at Tesla. He specializes in deep learning. It goes on. It's got an interesting thing there around joining Tesla as the head of Autopilot, and also a little bit of his work around generating selfies from his PhD. So that's good, right? It's a nice output. Well, we could actually compare that to what was on Wikipedia at the time when it was generated, and the answer was nothing. Right now, if you go there now, he's taking care of this. We brought it up with Tesla, and their PR department got onto this, but there was no Wikipedia page for him. And this is actually not just endemic to Andre. There's nothing particularly about him. But it's actually, Wikipedia has a massive recall problem. We think a lot about its precision, and we measure its precision, but its recall is actually pretty bad when it looks at things. And Andre is actually more likely to have one because he's a white male. If you look at people that aren't white males, particularly females not from America, you can see here a whole example of very, very prominent female scientists with no Wikipedia pages. Right? And what we were seeing on this is Wikipedia, as a result of our collective intelligence, actually also encodes a lot of our collective biases. So we can rectify that with machines, and we can start to generate these profiles. So we did this and put them up, and you can go to Primer's website, click on them, upload them into Wikipedia, and did this, and it was covered very nicely in this Wired piece. So you can see things like Joelle Pineau, again, an example of a very prominent scientist, and we've got now a Wikipedia profile that you can click through and upload. But it's not just people that don't have pages. You've got things like Alexander Kogan, you will know him from Cambridge Analytica fame. He's got a profile that's reasonable, but you can click through and see the last time it was updated was the 4th of April we'll get that date right, 26th of April 2018, right? But there's a whole bunch of stuff here that we're able to identify that happened after this that wasn't encoded into that. And you can think of that challenge, right? Keep up to date every single entity in the world with everything significant that's ever happened to them and put it into human readable text so that we can all access it. And this is actually a really big and really complex problem, and one that we're able to start to automate. We can measure the model performance. You can see here, this is not just against Wikipedia text, but the underlying Wikidata across 7 of the different key variables. And on 6 of those, we massively exceed what Wikidata was able to do. And on the 7th, we're pretty close. So again, you get measurable performance on top of this. Now, this is important, for us. What we're actually trying to do here is to compute the global state space of the world. All the entities, all the events, what happens to them, what they're connected, and how these patterns and dynamics unfold. And it's important to do this because we're living in a world, which I would term of the generation age, where it is increasingly cheap and easy to generate a reality that is almost indistinguishable from true reality by machines. And what should kind of jump out at you is how quickly this changes. So 2014, this is a GAN network, 2014 by Goodfellow. And then you see 5 years later, right? This is 5 years of progression where we are today. You can see this in terms of deepfakes. This is not Obama speaking, although it does look like him speaking. So running where we can generate reality that's almost indecipherable. He doesn't quite blink enough, by the way, if you've actually kind of followed this. The blinking is not quite right. But we can now generate these things, right? So if you don't know ground truth, if you've got nowhere to turn for ground truth, how do you know what's real and what's fake? An example of that is this is GPT-2 output. It's one of the fake outputs. This was published in Axios. They flagged it as fake, obviously. But you can read, and it actually looks pretty convincing, right? You can read through this, right? And we've actually got to a place where you can do sentences and also paragraphs. But what's interesting, if you read down to that final paragraph, right, you'll see Defense Secretary Jim Mattis, right? He's not the Defense Secretary anymore, right? He's the former Defense Secretary. Right, so that's a fact that's wrong. The second thing is he never said this, and we know everything that he's ever said that's ever been reported before, and we know this is the only time this information has ever emerged. This is the first seed of this information. And it's important to know the context of where information came from, because as information is seeded into the networks, it starts to propagate. And this becomes key attack vectors that are actually unfolding. And if you listen to some of the major Russian generals, this is very much part of their conflict strategy as they push it out. And to put that in perspective, you can see here the diffusion of information around QANON, right? It propagates and then goes through. So we're now in a place where you can create realities that are indecipherable from our own, and you can do that at a massive scale by automating a lot of the creation of images, text, and video. To counter this, you start to need some resemblance of ground truth that you can use to go back to and say, do I know who this entity is? Do I know the events they're part of? Do I know from other sources where this has come from? So you can hold it up as a mirror against some of the attacks that are unfolding. And we're going to see a lot more of this in the coming 12 and 24 months. And so it's something that is certainly that we're keeping our eye on top of, and it's interesting to see it all unfold. And thank you for that, and I think we got some questions. Thank you.
Thanks very much, Sean. So you deploy the software in government institutions and financial services companies, right? How do you think about the social aspect of this? How does the man and machine work together?
Yes, it's interesting. So one of the financial applications, the bank, they have every morning about 200 analysts come down and actually go through their own reports that they've written and start to summarize those. It's about 300 hours of work. And that's currently done every morning, right? So you can kind of do the math of how much that costs. We're able to reduce that down to about 25% of the time. And that nets out at about a $6 million saving for that bank. So one of the things that's really interesting about that, okay, you get the cost saving, but now you've got, haven't replaced the entirety of these analyst jobs. You've just taken about an hour and 15 minutes of them back every morning. So what's interesting is what they start to do with that time. And we've been really following, tracking kind of, well, what do you do when you've got an hour change?
Ping pong?
No, there's not as much ping pong and these things. But no, I mean, what's interesting is that the institutions haven't quite caught up yet. So they haven't quite realized that there's that time. So one of the things that they're starting to do is what we get back from the analysts is I get a chance to be curious again. I get a chance to kind of go and investigate and explore things that I wouldn't have otherwise seen or looked at. So I think there's a little window before that time gets reapportioned of real curiosity that's going to be really interesting.
And do you deploy this on-prem?
Yeah, we don't want to hold a lot of the customer data, whether it's financial or government orientated. So we do a lot of deployments on-prem for our customers. There's normally into cloud environments for them, and they're actually fairly well provisioned across that. We'll train all our own models on open source, unstructured information so that they don't go in cold, and they're aware of a lot of language that's been used previously, and then we can bring that in and do any final training on-prem with the customer.
Is there, last question from me, is there or maybe I missed the concept of graph database system analysis behind this as well, in addition to text generation and understanding?
Yeah, so you've got your storage of information, which will reside in databases that are good for storing text, right? But then on top of that, you've got a whole set of structured information from events that are geolocated through to kind of events being tied to entities and events being tied together to geographic regions and also connected together in chains of sort of implied causality. So underneath that is a graph of all the abstracted information from the text that's starting there. So yeah, you're playing between a few different databases, but if you try and do that on top of like an Elasticsearch, you know, your joins that are going to emerge on top of the derived information are going to just slow that thing down to being unusable.
How would your platform distinguish between, say, Cantonese, Mandarin, and Fuzhou, or Iraqi Arabic and Moroccan Arabic, which are not all the same?
Yeah, so you'll notice the flags that we put up there, and the Iranian flag, you know, it has a different kind of, yeah. No, that's right. But the Arabic that's spoken there, which is interesting for that, is quite different from the Arabic that we've spoken in the Emirates, right? So that's different. We work in simplified Chinese, which is the dominant thing. We don't touch Cantonese yet. But yeah, this is kind of like the variants of language and the regionalities of it between.
Hi, two quick questions. Back here. First, do you guys train for specific tasks like text summarization, or do you build a more language model similar to the OpenAI model that you talked about? And second, you seem to be calling out this knowledge base as a real differentiator for you guys. What do you use? What kind of sources do you use to create this knowledge base? How do you trust them, and how do you account for more novel information?
Yeah, so take the last question first there. So the data that we deploy on top of is the customer's data, right? So they're pretty well provisioned in terms of all the information that they've got inside of their organization. And they've sort of taken a lot of diligence to kind of determine is it good quality for them. So that side becomes actually quite important for them. The second question was?
Task specific versus a general language model.
Yeah, so we run with general language models as a grounding, but then we'll build on top of that for task-specific roles. And so one of the nice things is, you know, the models, the universal language models that you have today, the more they've seen is just generally, you know, beneficial, right? But then you want to go in and train that for the specific task that's in front of them. Now, there's a few different pieces that you can do for that, but a lot of it comes down to, you know, the more data that it's seen, the better it's going to perform. And I think that's probably a general rule for these things.
One of the big challenges in on-premises software is sometimes debugging or getting a hold of some special case that's causing an issue. Similarly with ML models, where you're doing training both on your public data sets and then on their data sets, and the models are not always deterministic in their output, how do you've got two factors combining that make it really difficult to figure out what's going on and you know, fix bugs or determine whether something's expected. Can you speak a little bit to the challenges you've encountered there?
Yeah, so look, you know, with on-prem deployment, you know, you've got to have, you know, people that can get in from our team and have hands on keyboards, right? And, you know, just throwing it over the fence and saying good luck with that is not probably going to work. So that's one piece of this. The second, you know, piece of this is, you know, stochasticity in models. Some models do have stochasticity inside of them, and you can kind of sample across a large number of iterations of that to reduce that down, and that's probably a nice strategy to start with. But if you are going to deploy a stochastic model, the customer needs to be aware that there is some stochasticity inside of this, right? Now, you know, the customers that we work with there, that becomes more about customer education if you're going to have that dynamic. But the other bit on top of this is you've got a bunch of human processes that you can measure performance against. And I don't think anyone's putting their hands up and saying, we've got this, right? So I think our customers really acknowledge that they're kind of in a bit of a hole when it comes to kind of that volume of information. And so if the price of that is working with our people that can do a deployment with hands on keyboards, and they've got to kind of go over the shoulder a little bit, then that's a price they can pay.
Sean, thank you. That was amazing.
Thank you.
What a great journey.